So now we're back to Godot docs, getting started. Our first 2D game, coding the player. All right. So in this lesson, we're going to add player movement, animation, and set it up to detect collision. All right. To do so, we need to add some functionality that we can't get from a built-in node. So we're going to add a script. We'll click the player node and click the attach script button. So the player node in this little script right there. So let's do that. Player node, script button. Okay. Let's see what we want to do next. All right. So in the script settings window, we can leave the default settings alone and just click create. So all this stuff is fine and we're going to create it. All right. So we got this script right here going on. Let's go back and check out what's next. So note, if we're creating a C# script or other languages, we can select the language anyway. So note, if this is our first time encountering GDScript, it's not. All right, so we're going to start by declaring the member variables of this object. Hold on. Start by declaring the member variables this object will need. Okay, yeah. Anyway, so we're going to declare these variables. So let's grab these right here, and let's put this at the top right under extends area 2D. So let's just highlight 1 and 2. Yeah, let's highlight 1 and 2 and then drop it off like this. All right, so that's pretty good right there. Looks good. All right, so let's go read about it. So using the export keyword on the first variable speed right here, export var speed, allows us to set its value in the inspector. This can be handy for values that we want to be able to adjust, like a node's built-in properties. All right. We're going to click on the player node and we'll see the property now appears in the inspector in a new section with the name of the script. All right. Click on the player node. Player node's highlighted, and right over here, player.gd, we've got speed right there. If we get rid of speed, watch this when we get rid of it. Watch it, and it's out of there. All right, so that's when we put export in front of it, it puts the thing over here so we can adjust it over here and set it in the code. All right, so let's get back to it. Warning, if we're using C#, we're not. All right, so our player.gd script right here should already contain a ready and process function. Let's see. Ready and process, it sure does. All right, let's go back. If we didn't select the default template shown above, we need to create these functions while following the lesson. Oh, okay. The ready function is called when a node enters a scene tree, which is a good time to find the size of the game window, right? So we're going to add this game window to the ready thing. So let's grab this right here, this screen size, I should say. And let's highlight 8 and 7 right here and drop it off like that. And now this, when we run it, so let's go back and run it without it. Let's press F6. We can see it has our guy right there in the corner. Huh? What? Hold on, what? How about now? All right, so there's nothing there. Okay, so that's better. And then when we add this, when we put this thing here, this get ready in the screen size thing, it does that. Although it did it without us doing, I don't think this has anything to do with that, honestly. I don't think this screen size has anything to do with it. I think that as long as it goes pass, as long as we say pass, the thing's gonna open. Yeah. And then our guy's up in the corner too. So we need to bring our guy down, and let's just leave this in there, this screen size thing, because we're going to use that later. All right, so let's grab this. Let's go over here. Is there anything else we got to do? Oh yeah, we got to put the guy in the middle. So let's come over here. Let's zoom out on this, and we can see our guy is up here in the corner. So let's put him in the middle somewhere like this and then run it again. And we can see our guys in the middle now. All right, so that's a little bit better. All right, let's go back to the script and get to the next section. All right. So now we can use the process function to define what the player will do. Also, this right here, what this is, let's go look at this before we go any further. Let's do a print on this, right? So let's come down here and say print screen size right there. And then let's do an F6. And we can see down here, it says 480 by 720. So the 480 by 720, which is the same thing over here, project settings in the window, 720, 480. So it just tells us this thing right here just tells us what the screen size is. All right. So we can use it later. All right. So there's that. What else? So now we can use the process function to define what the player will do. The process function is called every frame. So we'll use it to update elements of our game, which we expect to change often. Okay. For the player, we're going to need to do the following: check for input, move in the given direction, and play the appropriate animation. Okay. So first, we're going to need to check for input. And this is, is the player pressing a key or not? For this game, we have 4 directional inputs to check. Input actions are defined in the project settings under input map. We've already been there. Here we can define custom events and assign different keys, mouse events, or other inputs to them. All right. So for this game, we're going to map the arrow keys to the 4 directions. So we're going to click on project settings to open the project settings window and click on the input map tab at the top. So let's do that. Let's get rid of this real quick. And then F8. And then let's go over here. Project settings, input map. And we got that right here. So let's see what we got to do next. So now we're going to type move right in the top bar and click the add button to add the move right action. So let's do that. So let's say right here in add new action, move _ right. All right. And then add it. So we've got move right here. Let's come down here. So we need to assign a key, we need to assign a key to this action. We'll click the plus sign on the right. So this one right here to open the event manager window. So where it says dead zone and there's a plus next to the move right, that's where we're going to do this. So we'll come over here. We have the move right. We've got the dead zone. We've got the plus, and there's that. So now that we're here, the listening for input field should automatically be selected. All right. So they're talking about this right here or something. I don't know. And so we're going to press the right key on our keyboard and the menu should look like this now. So it'll say right, blah, blah, blah. Let's do that. So right arrow. Okay. Now what? Probably press OK. Select OK. Okay. So we can press OK, but you know what? I'm not cool with that. We need D to be right also. So let's add another one. Let's say D. And let's say OK. So we got move right is going to be right and D. There we go. So let's come down here. So repeat those steps for 3 more mappings. Move up, move down, move left. So let's come over here and let's do that. So let's say move left, move up. Let's do it, move up. Copy that. Let's do it. Control A, Control C, press enter, drop it off, backspace, left, enter, drop it off, backspace, down. There we go. All right. So now let's change these up a little bit. Also, I think we can just press this arrow right here and they'll move. No, that did nothing. That did nothing. We can move it up like that though. Cool. All right. So let's turn move left into A, enter. No. Just A. Okay. And then let's add another one and put left arrow. Okay. And then we've got up. We'll do W. Okay. We'll do the up arrow. Okay. Move down. We'll do S. Okay. And we will do down arrow. Although we don't even really need to do down arrow because I'm not even going to hit that thing. But whatever. Now we know. So there it is. Let's see what else we got to do. All right. So we did all those 3 things and the input map should look like this. It looks like this. Ours looks like this, but cooler, but better. but more awesome. Where'd it go? Yes, but more awesome. Let's bring this one up just so that it all looks the same. All right, cool. Close it. Great. Let's go to the next part. All right, so we're going to click the close. We already did that. Note, we only mapped one key to each input action, but we can map multiple keys. We know this. We just did it. Joystick buttons or mouse buttons to the same input action. True. So we can detect whether a key is pressing. What? We can detect whether a key is pressed using input dot is action pressed, okay? Which returns true if it's pressed and false if it isn't. And then we got this bunch of code. Let's drop this in the process since that's where it is. Let's grab it here. Come over here, highlight 12 and 11, drop it off. All right, so now we got that. Let's come back here and see what they want. So we start by setting the velocity to 0, 0 by default. Yeah, that's what the vector2 0 is. 2.0 is, pardon me. The player should not be moving. Then we check each input and add or subtract from the add and subtract, because we're adding if we're moving right and subtracting if we're moving left. Same with down and up. Remember, down is positive, up is negative when we're dealing with Godot. Okay. Then we check in each input and add subtract from the velocity to obtain a total direction. True. For example, if we hold right and down at the same time, the resulting velocity will be 1, 1. True. In this case, since we're adding a horizontal and vertical movement, the player would move faster diagonally than if it just moved horizontally. True, because that's not how it works. That's not how triangles work. A squared plus b squared equals c squared. So 1 squared plus 1 squared would be 2 squared, right? And then c would be the square root of 2, but that number. The square root of 2 is bigger than 1. So if it goes like this, it's going faster. You know, if it goes one diagonal at a time, it's actually faster than one horizontal or one vertical at a time. You can just go look at it. You know, we all know in a square, the diagonal line is longer than the sides. We know this. That being said, yeah, it said that. So we can prevent this if we normalize the velocity, which means we set its length to 1, then multiply by the desired speed. This means no more fast diagonal movement. All right, so here's a tip. If we've never used vector math before or need a refresher, we can see an explanation of vector usage in Godot at Vector Math. All right, so we're going to have to do this at some point. Not today. Not even until we're done with the actual checkers game, but we're going to have to get into this. And note, this tutorial is not a formal textbook on linear algebra. So we're probably going to have to go over here to Khan Academy and actually, accept all, yeah, and actually do this actual class. Yay! Not only are we learning computers, but we're learning algebra yet again. All right, can we get this thing off the screen, Con? We don't got any money. I would love to give you some money if I had some. Connie boy, what are you doing? Can we not get this thing off the screen? Is this like our life now? Oh, there it is. Oh, you got one here too. All right, Con, thanks. All right, I understand you need it, but man, oh man. Anyway, there we go. So yeah, we're gonna have to do that at some point. Not today though. Not anytime soon. Maybe next month actually. So we also check whether the player is moving, so we can call play or stop on the animated sprite. Okay. Is that what we did? Let's go look at that. So yeah, that's what they're talking here. This is the checking to see if velocity length is greater than 0, as in velocity. Remember, velocity is a vector 2. So if velocity dot length is greater than 0, that means there's 2 numbers being moved, right? You know what I'm saying? It means that the X and the Y both have different changes in it. All right. So then that's why we're going to normalize it right here. Let's actually print this out while we're at it. Print velocity. All right. So let's do that. Let's push F6, and we're going to be watching down here. Let's push F6. Let's run it. We're going up. We're going to the left. We're going to the right. Now let's go diagonal. You see, that's not 400. That's the normalized speed. All right. And so basically, velocity dot normalized times speed. Let's see. Let's come over here and let's say let's do above that. Let's say print velocity times speed. Print velocity dot normalized. All right, let's print that out. All right, let's do an F6. Do we have another print going on? That's why it was. We have 2 prints? No. All right, so let's run it. So here we go. There's that. And now when we do the velocity normalized, we can see that's the number. And basically what that number is 1 divided by square root of 2. Remember, a squared plus b squared equals c squared, right? So 1 squared plus 1 squared equals c squared. So that would be 1 plus 1, which equals 2. So c squared would be 2 squared. C squared would equal 2. So the square root. So c would equal the square root of 2, right? Yeah, we know that. Okay. Anyway, let me not do any more math without visualizing. So yeah, basically that's what that number is right there. So we just multiply this number here, which is 1 over square root of 2, and we do that times whatever the speed is, right? And that's how we get the diagonal speed. All right, and that's it. It's actually pretty easy. So let's go back to it over here. So we also check whether the player is moving, so we can call play or stop on the animated sprite 2D. Yeah, we just went over that sort of. So $sign is shorthand for get node. So the above code, this animated sprite 2D dot play with the $sign above it, they're talking about this part right here, actually means get node animated sprite 2D dot play. So it's looking for the node. It's going to look for the node in this list. It's going to look for this node, and then it's going to do the dot play method on it. All right. So that's basically it. Just a little shorthand. In GDScript, $sign returns the node at the relative play. It just does the get node. That's what it does. Since animated sprite 2D is the child of the current node, we use $sign animated sprite 2D, and that's it. Pardon me. So now that we have a movement direction, we can update the player's position. We can also use clamp to prevent it from leaving the screen. Clamping a value means restricting it to the given range. So we're going to add the following to the bottom of the process function. And we'll make sure it's not indented, all right? So let's grab this here. Let's come over here. Let's go down to the end of process. All right, so I guess a control end would work. Let's drop this off right here. And then let's go home and let's push this one over. Let's drop this down one more, all right? So let's look at what it does. All right, when we do this, we can go up like that and over like this. No big deal. Also, Let's go over here. Animated sprite 2D. I think it's over here. Animated sprite 2D. We have to put... I forgot to put one of the things down here. But I forgot how to do that. How do we get the sprites in there? Player? Yo, there it is. Up, walk. Okay, so we got... I put walk in up. So let's put walk in walk. Walk 1, walk 2. And let's put up 1. Oh, let's get all these out of here. Get out of here. Get out of here. Get out of here. And let's put up 1, up 2. All right. They're different things. Yeah, I messed up on the last one. So make sure we do that. How I did that was we just have to open up this animation thing. I'm pretty sure it opens up for us. If we click this sprite thing, this thing right here. Let's get out of this area. Let's do this. How do we get out of this? How do we... I don't know. Okay, there we go. All right. Well, anyway, somehow we got back in there. I forgot how we did it, but yeah, make sure you change this stuff up. It's got to look like that. All right. So let's go back to over here and see what we were doing. So we also had the clamp. Oh yeah, we did this. So let's come back over here and let's look at this script and we put this clamp and stuff on there. How do we get this out of here? We just got to click player or something. I don't know. Anyway. That worked good enough. So this brings it up and then player. All right. So we see we did this and we got the clamp and we got the position. So let's run it. And you see now our thing moves like this. Did we put an up? Why isn't it doing up? Oh, we didn't tell it to do up. All right. Whatever. Anyway, so there's that. And we can also see here that because of the clamp screen, we can't go off the screen. Okay. Once the middle hits this part, it's not doing it anymore. It's not going anymore. And we can prove that. We can take this, get rid of it, and then run it again. And then we can see we can go all the way off the screen. No big deal. Wee. All right, great. So let's leave the clamp there. Boom. So let's go to the next part. Look how much we got left. So tip, the delta parameter in the process function refers to the frame length. True, we already know that. The amount of time that the previous frame took to complete, we know this. Using this value ensures that our movement will remain consistent even if the frame rate changes. Yes, if you go back and look at that one video, we went all over that. Click run current state, we already did that. Warning, if we get an error, we didn't. So here we go, choosing animations. Now that the player can move, we need to change which animation the animated sprite 2D is playing based on its direction. We have the walk animation, which shows the player walking to the right. This animation should be flipped horizontally using the flip H property for the left movement. We also have the up animation, which should be flipped vertically with flip V for downward movement. Okay. So let's place this code at the end of the process function. So we got flip H to flip horizontally for the left and right, and flip V for the up and down, right? So here's the stuff we're going to have to add this to the end of the process function. Let's grab it and add it first, and then we can go over it. So let's go down here to 30 and drop it. Let's go 30, tab over 1, and then drop it. And then everything after 31 and on, let's tab it over 1 time. All right, so there we go. So let's go over this. Actually, let's get this and bring it down. Whoa. Let's grab this and bring it down here so that we keep our ifs with our ifs and our position changes with our position changes. All right. So, and we should be doing comments here too. So let's put a comment here. Let's say flip animations for directions. That's good enough, right? And this one's hashtag normalize diagonal speed. There we go. That's good enough. So let's come back over here and see what we got to do. Okay, so now this is going to go through it. So the Boolean, so here's a note. The Boolean assignment in the code above, assignments in the code above are common shorthand for programmers. Since we're doing a comparison test, a Boolean, and also assigning a Boolean value, we can do both at the same time, okay? What they're specifically talking about is this right here. As you can see, actually all of them. What? No, just this one and this one. Are they all like that? I can't tell. Anyway, so this is basically like the comparison operator in JavaScript, except for we have the command first, then we have the condition after that, and it's only what we do if true. We don't have an else involved with this. So basically that's it. This flip H if this is true. Flip V if this is true. All right. And that's it. And it's the same as saying velocity.x is less than 0. Velocity.x is less than 0. If that's the case, do this. If not, don't do anything. And that's basically what we're doing here. So let's come down here and do the next thing. So we're going to play the scene again and check that the animations are correct in each of the directions. Let's do that. F6 up. Yes. Look at this eyeball looking up. And then over and switch and switch and switch and up and down and up and down and up and down, and we're good. All right, great. F8, get out of here. So now we're on to this next part. Let's see. Here's another tip. A common mistake here is to type the names of the animations wrong. Yeah, we know that if it's capital, it's got to be capital. If it's lowercase, it's got to be lowercase. We know about that. When we're sure the movement is working correctly, we can add this line to ready, so the player will be hidden when the game starts. So we're going to add this hide in ready, so it's hidden when it starts. So let's come over here, and where's ready? Right here. And let's drop this off right, not like that, right here. All right, and so when we run it, where's our guy? It's hidden. We hit it. All right. So next, preparing for collisions. Put your seatbelt on. That's one. Okay. Anyway, we want the player to detect when it's hit by an enemy, but we haven't made any enemies yet. What? That's okay, because we're going to use Godot's signal functionality to make it work. Oh yeah, we are. Signals. But they still haven't taught us how to make custom signals, but we will find out. They're not going to, we're not paying money to learn this stuff. Okay. That's not happening. Anyway, so we're going to add the following to the top of the script. If we're using GDScript, add it after extends area 3D. If we're doing something else, do something else. All right. So this is going to be right after extends area 2D. So let's come over here, right at the top. Let's drop it down one. Boom. We've got signal hit. All right. So now let's come back over here. This defines a custom signal called hit that we will have our player emit or send out when it collides with an enemy. We'll use area 2D to detect the collision. Pardon me. We're going to select the player node and click the node tab next to the inspector tab to see the list of signals the player can emit. Yeah. So over here, we got player selected, and we're selecting node right here. We've got all these right here. We've even got hit at the top. Let's go over here. So notice our custom hit signal is there as well. We saw that. Since our enemies are going to be rigid body 2D nodes, all right, so this is something different than what we with our other guys is. We want the body entered body node 2D signal. So this one right here. This signal will be emitted when a body contacts the player. We're going to click connect, and the connect a signal window appears. All right, so let's see. Hit over here. What do we want to? entered body, this thing. And so the connect is this little red thing right here. Or just double click it. All right, there it is. Double clicked it. We got here the connect to a signal method box, whatever. All right, so we did that. Godot will create a function with that exact name directly in the script. We've done this before. And we don't need to change the default settings right now. So let's just send it in there. Let's connect it. And we can see down here at the very bottom, we have this thing just like when we did that on the last video, or whenever we did that last. Here's another warning. If we're using an external text editor, a bug currently prevents Godot from doing so. Okay. All right. Well, in that case, we're going to have to write it ourselves. Well, maybe one day, but not today. Note the green icon indicating that a signal is connected to this function. What? So note the green icon indicating that the signal is connected to this function. Let's take a note of that. This does not mean the function exists, okay, because we haven't even declared it yet, right? Only that the signal will attempt to connect to a function with that name. So double check that the spelling of the function matches exactly. On body entered? Yes, it do. On body entered. There it is. Next, we're going to add this code to the function. All right, so let's take this, copy it. Let's go over here, and where are we? 45. Let's highlight 46 and 45 and drop it off like that. All right. Keep going. Let's go. So we did that. Each time an enemy hits the player, a signal is going to be emitted. We need to disable the player's collision so that we don't trigger the hit signal more than once. Okay, so that's what's going on here. We're going to hide every time we do on body entered. We're going to hide the player because that means it's dead. The player's, that's one life gone. We're going to hit emit so that it, we're going to do the hit emit so that it emits the hit thing and then does whatever it does. We'll figure that out later. And then collision shape 2D dot set deferred. So we're going to use this to find the node collision shape 2D, and then we're going to do a set deferred disable, whatever that is. So each time we said that, we need to disable, and we said that, right? So disabling the area's collision shape can cause an error if it happens in the middle of the engine's collision processing, okay? So if we do this at the wrong time, this, what? Disabling. If we do this at the wrong time, I guess, it'll be bad. So using set deferred tells Godot to wait to disable the shape until it's safe to do so. Okay, so this is just like a little safety catch right there to prevent bugs. So the last piece is to add a function we can call to reset the player when starting a new game. So we've got func start pause, position equals pause show, and then we've got we're going to look for collision shape 2D, and we're going to say disabled, whatever it is, it's going to be false now. So if it was true, it's false. If it was false, it's true. Or is it just going to be... Yeah, that's how that works. All right, so let's grab this and let's drop this at the end of the thing. So we've got this func right here. Let's drop it down one, bring it back one, drop it down one more, and then drop it right there. So we've got this thing right here, and this thing with this thing's gonna call to reset the player, right? So when we go over here and we run it, shut up. F6, I mean, we can see he's still not there. So we're going to have to probably deal with that in the next one. All right, so let's go back over here. And with that, we are finished. So there's a lot of user notes. There's 38 of them. And so if you got some problems, there's probably going to be an answer in here. But I think we got through it all right. So we can just go to the next one. So there's that. Let's come over here to the next one. So now we're on to creating the enemy, and we'll see you next time.